Got another question for A-level chemistry multiple choice practice. So this is the second of the organic ones. As always, the link to the questions in the description of the video if you want to try it first. And I really hope you like the video. And if you haven't already subscribed, why don't you think about subscribing to the channel? Question 1. The standard used to zero NMR chemical shift measurements is TMS for short, tetramethylsilane. So option A is the answer there. Question 2. So for it to be an amide, first of all, it has to have a C double bond O directly bonded to an N. So that rules out A and B. And for it to be a secondary amide, you've got to have two carbons directly bonded to the nitrogen. So option C was the answer. Question 3. So a nucleophile needs a carbon delta plus to donate a pair of electrons to. You've got carbon delta pluses in A, C and D, so B is the answer. Question 4. So alicyclic means we've got a ring, but it can't be a benzene ring. So C is the answer. Question 5. You'll notice B is an alkane, C2H6. It's tetrahedral arrangement around the carbons. So obviously that's not planar. You've got bonds sticking out and going back. Question 6. So there's the skeletal formula for this structural formula. You'll notice this dotted line here is representing a line of symmetry. So that means that these hydrogens are equivalent. So that's one environment. They are 2. That's unique. 3. And don't forget about there's a hydrogen there. So 4. So B is the answer. Question 7. You'll notice I've already ruled out B because that's got 100% atom economy because it's an addition reaction. There's no waste products. So for the other 3, I've had to work out the percentage atom economy. So that's the MR of the desired product divided by either the MR of all of the products or all of the reactants multiplied by 100. So you can see C's got the lowest percentage atom economy, so that's the answer. Question 8, memory test really for the 2 propagation steps for the breakdown of ozone by NO radicals. So you can see that the second propagation step we've actually got as option D. Question 9, so I've annotated the key absorptions there. We've got an OH of an alcohol and we've got a C triple bond N. So which molecules got those in? Option B. Question 10, so this type of reaction is an acylation reaction. So what do you need to get an acyl group onto a benzene ring? You need an acyl chloride, which is option C. Question 11, so before we go into whether it's chiral or not, how many structural isomers are possible that are straight chain? So the chlorine can either go at the end, so 1 chloro, 2 chloro, 3 chloro, or 4 chloro. So if we think about 1 chloro, if the chlorine's here, we've got 2 hydrogens on there as well, so there's no chiral carbon in that one. If we think about 2 chloro, so we've got a methyl, a chlorine, a hydrogen, and then this thing, so that is chiral. 3 chloro, so we've got chlorine, hydrogen, ethyl, and then this thing, so that's chiral. 4 chloro, chlorine, hydrogen, but that is the same as that, so that one isn't chiral, so the answer is 2, so it's B. Question 12, we're talking about this peak here. You'll notice I've already ruled out B and D because this cannot produce this fragment. If you look at the structure of that, we don't have that, neither do we have this. So all we need to do now is add up the MR of the atoms. You'll see C has 43, so that's your answer. Question 13, which statement or statements support the delocalized model for the structure of benzene? All carbon-carbon bonds of the same length. Yep, that's correct. Statement 2, enthalpy change of hydrogenation of benzene less exothermic than expected. Yep, that's another one. Bromine reacts with benzene less readily than with cyclohexene. Yep, that's right as well, because to get bromine to react with benzene, you need a catalyst. All 3 correct is the answer. Number 14, so which of these are true about recrystallization? Organic compound more soluble in hot solvent. That's right. Statement 2, hot solution cooled before the purified organic compound is collected. That's right as well, because you plunge it in an ice bath to get the crystals back. Statement 3, you'll see I've written there, impurities lower melting points. So the melting point of the purified organic compound will actually be higher than the impure one. So that statement was wrong. 1 and 2 correct. B is the answer. And question 15, which of these could react with this to form a carbon-carbon bond? If we think about the first one, we've got a haloalkane and an AlCl3 catalyst, that is. So we could put a methyl group on to the benzene ring using that. So that one was right. KCN in ethanol, so that would substitute the bromine for the CN group, the nitrile group. So you'd get that, and you can see you have got a C-C bond formed. There it is there. So that one was correct. And the ethanol and sulfuric acid, well, that's going to form an ester group here with the carboxylic acid OH, which will give you that ester there. We haven't formed a carbon-carbon bond. That was wrong. So 1 and 2 only. B is your answer.